All right, let's dive in. Our listeners have sent us a mountain of info on the future of computing and AI.
Yeah.
And a lot of it centers around Jensen Huang, the CEO of NVIDIA.
Of course.
So we're going to unpack his predictions on how AI is going to, well, really revolutionize everything.
I think he's really become one of the leading voices in this space.
Yeah.
I mean, NVIDIA's GPUs, those graphics processing units,
Right.
they're essential now for
Yeah.
AI development. And he's got some pretty bold ideas about where this is all headed.
So to start,
Yeah.
he talks about the end of Moore's law.
Right.
Which, for anyone who needs a reminder, basically states that computing power should double every 2 years.
Yeah.
It's been the engine of technological advancement for decades.
Yeah, it has.
But, you know, it's slowing down. What's happening?
Well, imagine you keep trying to fit more and more people onto a bus.
Oh, okay.
Eventually, you hit a limit.
Yeah.
You just run out of space.
Right.
That's kind of what's happening with Moore's law. Okay. We're hitting the physical limits of how small we can make transistors.
So the building blocks of microchip.
Exactly. The building blocks of computer chips.
So that free ride of like ever-increasing computing power that we've been enjoying, it's coming to an end.
It is.
So does that mean progress is going to grind to a halt?
Not at all.
Okay.
This is where Huang's idea of accelerated computing comes in.
Yeah.
So instead of just relying on CPUs, those general purpose brains of our computers,
Right.
he thinks we need to turn to more specialized processors, like GPUs.
Okay.
Think of it like this.
Okay.
Instead of one bus trying to carry everyone, you have different types of vehicles optimized for different tasks. You know, a school bus for students, a van for deliveries.
I see where you're going.
Yeah.
So GPUs, which were originally designed for video games,
Pretty much, yeah.
are now becoming these, like, workhorses of AI.
Exactly.
Okay.
We can handle these massive amounts of data and complex calculations that AI needs much more efficiently than traditional CPUs.
Right.
And this kind of leads us to what Huang calls the shift.
Yeah.
From software 1.0
Okay.
to software 2.0.
Software 1.0 versus 2.0.
Right.
I have a general idea, but
Yeah.
break it down for me like I've never heard of it before.
Okay, so software 1.0 is the way we've always written code. It's humans giving the computer step-by-step instructions. Think of it like writing a recipe.
Okay, yeah, I can follow that.
All right, so then software 2.0,
Yeah.
that's about machines learning from data
Okay.
instead of humans explicitly writing the code.
So like,
So let's say you want to teach a computer to recognize cats.
right.
Instead of writing this long program with specific rules about, you know, whiskers and ears, you just feed it a ton of pictures of cats.
Oh, okay.
And it figures out the patterns on its own.
So you're telling me that
Yeah.
the software that's in a lot of the apps that I use every day is essentially learning and evolving on its own.
Yeah, it really is.
That's kind of amazing
It is.
and a little unnerving
Yeah.
at the same time.
Yeah, for sure.
Okay, so this is all thanks to neural networks,
Right.
which is a type of AI that excels at learning from data.
Exactly.
And those run really well on those GPUs that we were just talking about.
Yeah, they do.
Okay, so this software 2.0 is already all around us.
It is.
Give me like an example of something I might be interacting with on a daily basis.
Think about the facial recognition on your phone.
Oh,
That's software 2.0 at work.
okay.
It's not a human programmer who coded in all the rules for recognizing faces.
Right.
It's a neural network that's learned to do it by being trained on a huge data set of images.
That's amazing. I never even thought of it like that.
Yeah.
So we've got this shift from Moore's law to accelerated computing, this paradigm shift in software development.
Right.
How does NVIDIA fit into all of this?
Well, they're not just providing the GPUs. That power AI, they're also building what Frank calls the instruments for AI.
Okay.
And that leads us to their latest creation,
Yeah.
which is the Blackwell supercomputer.
He made it sound like Blackwell is a total game changer.
It really is.
Give me the rundown.
Okay, so
How powerful is this thing?
imagine walking into a room filled with racks of computers.
Okay.
Each one the size and weight of a small car.
Wow.
That's Blackwell. And each rack
Mhm.
consumes a ridiculous amount of power.
Like, how much are we talking?
About as much as a small neighborhood.
Wow.
Yeah.
So it must be a beast.
Yeah.
Why does AI need this level of computing power, though?
Well, the AI models that we're building are getting ridiculously complex.
No.
You know, think about the human brain. It's incredibly sophisticated,
Right.
billions of neurons
Yeah.
connected in these complex networks
Uh-huh.
to create AI that can even approach human-level intelligence.
Right.
We need computers powerful enough to simulate those vast neural networks.
It sounds like we're talking about more than just faster calculations here.
We are, yeah.
This is about pushing the boundaries of what AI can actually, understand and achieve.
Right, and the size and complexity of these models just keeps growing.
Yeah.
And that's why Huang talks about these scaling laws of AI.
Scaling laws.
Yeah.
Tell me more.
He describes two key scaling laws.
Okay.
The first one
Hmm?
is the scaling law of training.
Okay.
The bigger the model
Yeah.
and the more data you feed it,
Okay.
the better the results you get.
It's like the more an athlete trains, the better they perform.
Right,
The
exactly.
more an AI
Yeah.
practices, the better it gets.
Right.
What's the second
The
one?
second one is the scaling law of inference.
Okay.
Inference is basically
Mm-hmm.
the AI thinking about a problem.
Okay.
And Huang argues that the longer you let an AI think,
Mm-hmm.
the higher the quality of its answers will be.
So it's not just about speed.
No.
It's about giving the AI time to process information and really reason things out.
Exactly.
Like, sometimes I need a minute to think before I can give a good answer to a question.
Right, exactly.
It's not just about quick reactions.
Right.
It's about deeper reasoning and planning.
Yeah, and Huang gives this great example.
Okay.
If you ask an AI what its favorite Indian food is,
Mm-hmm.
it might just immediately say chicken tikka masala.
Yeah.
But if you ask it to plan, a complex trip from London to Tokyo,
Yeah.
it needs time to consider all the variables, just like we would.
That's a great way to illustrate the point.
Right.
So we're talking about AI moving beyond these, simple tasks
Mm-hmm.
to actual problem solving and decision making.
Yeah.
That's where things get really interesting.
It is, and that's where he starts to talk about these AI agents,
Right.
which he sees as the next generation of AI,
Okay.
capable of doing much more complex tasks.
Right.
But I think we should probably save that for part 2
Yeah.
of our deep dive.
We've covered a lot of ground already. We've gone from the end of Moore's law to the rise of accelerated computing, this crazy concept of software 2.0,
Mm-hmm.
the insane power of NVIDIA's Blackwell supercomputer.
Right, and that's just scratching the surface.
It is. We've only just begun,
Yeah,
but I think we've given our listeners plenty to think about for now.
definitely. It's pretty amazing how fast AI is evolving,
Right.
from self-driving cars to personalized medicine.
Right.
It feels like we're on the cusp of a revolution.
Yeah.
And according to Jensen Huang,
Mm.
AI agents are going to be leading the charge.
Okay, so remind me,
Yeah.
what are these agents?
Okay.
I mean, it sounds like something out of a sci-fi movie,
Yeah,
but I have a feeling they're a lot more grounded in reality.
you're right. They do sound futuristic.
Yeah.
Think of them as
Yeah.
incredibly intelligent digital assistants
Okay.
that can do way more than just set alarms or play music.
Right.
They can understand complex requests,
Mm-mm.
anticipate our needs, even take actions on our behalf.
Okay, so they're like
Yeah.
Siri or Alexa on
Yeah.
steroids.
Yeah.
What makes them so different from the virtual assistants that we already have?
The key difference is their ability to reason,
Okay.
plan, and execute tasks
Mm-hmm.
in a way that really resembles human intelligence.
Okay.
And they're built on top of these large language models that we were talking about,
Right.
which means they have this deep understanding of language
Uh-huh.
and a vast knowledge base to pull from.
Okay, that's pretty impressive.
Yeah.
But how does an AI agent actually work?
Okay, so
What's going on behind the scenes when I ask it to do something?
right.
Like book a flight or write a report.
Well, imagine it as this multi-stage process.
Okay.
First, the agent has to perceive the world around it,
Yep.
just like we do through our senses.
Right.
And it gathers info from different sources,
Right.
text, images, sensor data, even your personal preferences.
So it's building like a digital picture of the situation.
Yeah, taking in all the relevant details.
And what happens next?
So then the agent needs to reason about what it's perceived.
Okay.
It has to understand the context,
Okay.
identify the goals or objectives,
Yeah.
and figure out what needs to be done
Got it.
to achieve those goals.
So it's not just blindly following instructions.
It's not, no.
It's actually making decisions
Yeah.
based on its understanding of the situation.
Right. And this is where the power of those large language models really comes in.
Okay.
The agent can actually draw on its knowledge
Mm-hmm.
and reasoning abilities to come up with a plan.
So it's like having a super smart assistant
Yeah.
who can not only understand your instructions,
Uh-huh.
but also figure out the best way to carry them out.
Right, exactly.
What kind of tasks are these agents actually capable of doing?
Well, Huang gave a few examples.
Okay.
He mentioned marketing agents
Okay.
that could personalize campaigns, target specific audiences,
Right.
customer service agents that could handle complex inquiries and solve issues.
Okay.
And even chip design agents that are helping NVIDIA engineers design better GPUs.
Chip design agents.
Right.
So
Yeah.
they're not just doing routine tasks.
Bro.
They're actually contributing to creative and innovative work.
Right.
That's mind-blowing.
It is, and it kind of brings up the question
Yeah.
of whether AI is going to replace human jobs.
Right. Is this the beginning of the end?
That's what a lot of people are worried about.
Yeah.
But Huang's vision is more about augmenting human capabilities,
Okay.
not replacing them.
Right.
He talks about agents supercharging employees,
Okay.
making them more productive.
So it's this collaboration
Yeah.
between humans and AI,
Right.
where each is leveraging their own strengths.
Exactly.
Okay, I like that. That's a little more optimistic
Yeah,
than I think a lot of people's outlook is.
it is.
But how do we ensure that these agents
Yeah.
are being used ethically responsibly?
It's definitely something we have to think about.
Yeah.
As AI becomes more and more sophisticated,
Right.
Huang really emphasizes the importance of guardrails,
Yeah.
control mechanisms,
Right.
These agents need to be trained, evaluated, and monitored,
Yeah.
just like human employees.
It makes sense. We can't just unleash these incredibly intelligent agents into the world
Right.
without thinking about the consequences.
We can't.
So where do we go from here?
Well, Huang believes the next frontier is what he calls physical AI.
Physical AI.
Yeah.
Okay, now that sounds like something straight out of a sci-fi novel.
I know, right?
I'm all ears. Tell me more.
Think about robots,
Okay.
autonomous vehicles, smart factories, even entire cities
Wow.
managed by AI.
So this is AI interacting with the real world,
Exactly.
controlling physical objects and systems.
Right. And that's the potential of physical AI.
Okay, that's both really exciting
Yeah.
and a little bit intimidating.
Yes.
It feels like we're on the edge of something huge.
Yeah, we are.
How does NVIDIA plan to make this happen?
Huang says we need 3 types of computers to make this work.
Okay.
First, you have the DGX computer.
Right.
That's the one we talked about earlier.
Yeah, for training the AI models.
Exactly. Giving them